PhD student working at the University of Colorado in Boulder. Through the NASA Aeronautical Scholarship Program, I was able to spend my summer here at Glenn Research Center in Cleveland, Ohio, working with my mentors Dave Davis and Dave Saunders. And together, we have been working on the large-scale inlet mode transition experiment, also known as LIMEX.
What you're looking at here is a mode transition, which LIMEX was developed to study. A mode transition refers to the opening and closing of the doors, called cowls, switching between the different engines. In this case, it is for a turbine-based combined cycle engine, called a TBCC engine for short, with a turbojet first stage and a ramjet second stage that can operate in tandem or independently. You probably know the first TBCC-like engine without knowing it. It was the J58, which powered the SR-71 Blackbird. Now, the SR-71 had the same engine configuration as most fighter planes, a turbojet with an afterburner. However, what made the SR-71 special was that the engine thrust could be increased at high speeds by bypassing the turbine and pulling all that extra air into the afterburner, simulating a ramjet. This made the SR-71 the fastest manned aircraft to ever fly, a record it has held for almost 4 decades. Another application of a TBCC engine would have been the National Aerospace Plane, or NASP for short. The goal of NASP was to create a reusable launch vehicle that will use the oxygen in the air to bring a spacefaring vehicle close to the edge of our atmosphere instead of climbing all the way up carrying its own oxidizer tanks, like rockets do. LIMEX was designed to explore inlet designs for a vehicle similar to NASP. The TBCC engine technology has the potential to make space travel much cheaper, but of course presents its own challenges.
Earlier, you saw me in front of NASA Glenn's 1-foot by 1-foot supersonic wind tunnel. This is their 10-foot by 10-foot supersonic wind tunnel, where the LIMEX model is actually tested. Behind me, you can see a model. It's not the LIMEX model, but it's representative of the kind of models we test in this wind tunnel. My job was to take all that test data and see, well, what is the flow actually doing as it's moving through the inlet? This helps researchers determine if they have to make any design changes to the model in the future to make it work even better. I hope my video helped give you some insight into what NASA does in the realms of high-speed inlets and show you how much fun it can be to be a NASA intern. Thank you so much for joining me.